Hi, my name is Madeline Marshall. I'm a PhD student at the University of Melbourne, and today I'm going to tell you about work that we've been doing using the Hubble Space Telescope to try and detect the emission from quasar host galaxies at redshift 6. So in the very early universe, we observed supermassive black holes with masses of 10 to the 8 or even 10 to the 9 solar masses. These black holes are almost as massive as the biggest black holes we see in the local universe, but they've somehow formed in less than 1 billion years. And so this raises a lot of questions about how they could have grown so quickly. Something that we can use to try and understand this intense growth phase is by looking at what kinds of galaxies and environments these high redshift quasars live in. So currently we're able to observe high redshift quasar host galaxies in the rest frame FIR-Infrared. This is redshifted into the sub-millimeter and is generally observable with ALMA. This traces the gas and dust distribution within the galaxies, but unfortunately we can't see the stellar emission in galaxies, which is produced in the rest frame UV or optical. The reason for this is at high redshifts, what you see when you observe a quasar, as you can see here, is just the PSF of the telescope. And so what needs to be done to detect the underlying host galaxy emission is by modeling the PSF, here done by using observations of a star, modeling the quasar, subtracting it off and seeing what's left over. Now, this technique has been shown to work well at low redshift, but at high redshift, this study by Myra Meckley back in 2012 is really as good as we can do. So this study found only upper limits on the UV magnitudes of the quasar host galaxy. So what we've been doing is extending this work using 6 additional high redshift quasars. We have observations of the hot dust-free quasar SDSS 0005-0006 and 5 quasars that were selected as they are relatively faint in the UV, but bright in the FIR-Infrared. So I won't go into too many details about the observing strategy. You can pause the video and have a look if you're particularly interested. But basically we observe each of the quasars for a couple of orbits with HST, and then we use the PSF-MC software to model the quasar, subtract it off and see what's left underneath. So here I show you the images produced for SDSS 0005-0006. So on the left here we have the image out of the telescope. So we've got the quasar shown as the PSF in the middle, and we see 3 surrounding companion galaxies. Using PSF-MC, we find the best model for this system. We have a just a point source model for the quasar, and then models for the 3 companion galaxies. If we subtract just the quasar emission, we get this image here. And if we subtract the full model, we're left with this residual image. I'll just show you briefly the images for the other quasars. If you're particularly interested, obviously you can pause and have a look. So what we find with our study is that we have no detections of the quasar host galaxies. So the residual flux that you saw in the center of the residual image is just noise left over from the quasar subtraction technique. And so what we find is that we have 2 sigma upper limits of about 22.7 in the J band and 22.4 in the H band. So here I show the these upper limits relative to some predictions from the blue tide simulation. So this is the galaxy versus AGN brightness, and our limits are shown here as the colored points. What you can see for the blue tide sample is that we really expect the quasar host galaxies to be about a magnitude fainter than we are currently able to probe with our HST images. And really what we need is increased resolution and thermal stability, and that's exactly what James Webb will provide us. So we can convert our UV upper limits to stellar mass limits, and use these to plot the black hole stellar mass relation. So here, our colored points are the upper limits on stellar mass. And we find that these limits are consistent with the black hole stellar mass relation observed with sub-millimeter observations of redshift 6 quasars, which are shown in the gray. And we also see that our observations are consistent with the local redshift 0 relation. So if you noticed, in all of the quasar images, we actually see nearby galaxies around the quasars within about 3 arc seconds, which is 18 kiloparsec, redshift 6. And so we find that 9 of these companion galaxies have colors and magnitudes consistent with being redshift 6 star-forming galaxies. So here we have the color and magnitudes effectively of the potential companion galaxies. They are the colored points. Open symbols denote companions where we think they either have colors that are inconsistent with, or they have magnitudes that are inconsistent with being at high redshifts. These 9 filled points are the companions that we think have colors and magnitudes that are consistent with them actually being at redshift 6. And this may indicate that these companions have, these quasars, have high redshift companions that may be causing interactions in the host galaxy. Now, comparing this observed density of companion galaxies to what we would expect from clustering measurements, we find that the quasars are in dense environments, but this is what is typical for redshift 6 galaxies based on high redshift clustering measurements. And so we find that these quasars have potential nearby companions, but unfortunately we don't actually have the redshifts for these. So we really need follow-up observations to confirm the redshifts of these companion galaxies. Now, this is one thing that we actually are planning on doing with Roger Windhorst's guaranteed time on James Webb. We are observing 2 of these quasars with the near-spec IFU. These quasars both have companions within the field of view of near-spec, which will allow us to confirm the redshifts of the companion galaxies. And also, very hopefully, we'll be able to use this PSFMC software and these new images to detect the host galaxies in the rest frame UV for the first time. Now, this paper is currently under review and hopefully will be out on the archive very soon, so stay tuned. But if you're interested in finding out any more details or have any questions before then, please just get in contact with me. In the meantime, if you're interested in the host galaxies of high redshift quasars, please see also a paper that I've recently put out showing predictions for redshift 7 quasar host galaxies using the blue tight simulation at the archive link below. Thanks so much for your time.